February 1943. The desert wind carried a fine mist of dust across the barren landscape of Tunisia, where the German Afrika Korps, fighting a desperate, fading war, made one of its most curious discoveries. In a captured Allied depot near Kasserine, engineers from the 10th Panzer Division stumbled upon a nearly intact American M4 Sherman tank, abandoned during the chaos of retreat. The machine, still warm from recent use, appeared crude at first glance: thick-welded armor plates, basic contours, a blunt turret, and wide rubber-padded tracks. To the Germans, who prided themselves on the sleek geometry of their Panzer IVs and the emerging technical marvels of the Panther program, it looked like something built by blacksmiths rather than engineers. Yet the moment they started the engine, that arrogance began to waver. The Sherman's six-cylinder radial roared to life with startling ease. Where German tanks often demanded coaxing, careful clutching, gentle throttle control, and an understanding of temperamental machinery, this American vehicle started like a truck. Its Continental R975 air-cooled engine hummed with a steady, unflappable rhythm. Oberingenieur Kurt Weidemann, one of the Afrika Korps senior mechanics, jotted his first observation: runs without protest. No oil sputter. No temperature spike. It was an unremarkable note on paper, but to a German accustomed to coaxing finicky Maybach engines to behave, it was quietly astonishing. They drove the captured Sherman across the field, over sand ruts and shallow dunes, expecting it to stall or overheat. It didn't. The suspension, based on a simple vertical volute spring system, absorbed the jolts without issue. There was no clattering or loose fittings, no metallic protest from the drivetrain. Within minutes, even the skeptical engineers fell silent, watching as the vehicle handled terrain that frequently crippled their own panzers. It wasn't elegant, but it was dependable, built for soldiers rather than specialists. Back at their forward maintenance station, the engineers dismantled panels and examined the internals. Everything seemed deliberately simple. Bolts could be removed with standard wrenches, engine parts were clearly labeled, lubrication points were obvious. Where a German tank required multiple specialists to service, the Sherman looked designed for a single field mechanic. The gearbox was coarse but robust. The electrical system lacked sophistication, yet it functioned flawlessly. Each discovery challenged another layer of their assumptions about Allied industry. Weidemann's report, later transmitted to the Heereswaffenamt in Berlin, noted something that struck at the core of German industrial philosophy: the enemy has built a machine not for admiration but for endurance. It was a statement that bordered on heresy in a culture obsessed with mechanical perfection. But the results were undeniable. The Sherman's air filters still operated effectively after miles of dust exposure. The clutch, though heavier than a Panzer IV's, showed almost no signs of wear. Even the cooling system, often the Achilles heel of heavy German designs, remained consistent. For comparison, a nearby Panzer IV Ausf. G had suffered a transmission seizure the same morning after just an hour of movement. The juxtaposition could not have been clearer. The Sherman was not superior in armor or gun power, but in one decisive respect: it worked. It did so without coddling, without temperamental quirks, and without the need for a fleet of mechanics following behind. By evening, when the engineers sent their findings to headquarters, the tone had shifted from ridicule to reluctant admiration. One entry summed it up with military brevity: engine tolerances high, material quality moderate, yet functionally unmatched under stress. For the first time, German technicians began to realize what American industry had achieved: not the creation of a perfect tank, but a perfectly usable one. In the broader war, this philosophy, quantity with reliability, would prove more decisive than craftsmanship alone. As the desert sun set behind the dunes, the Sherman idled in the background, exhaust curling into the dry wind, its rhythmic engine echoing through the camp. It wasn't beautiful. It wasn't precise. But it was alive, unbothered by the dust and heat that tormented its German counterparts. To those who witnessed it, the moment was quietly unsettling, a glimpse into why, despite German ingenuity, the war was slowly tilting toward the Allies. The testing reports from Tunisia were quietly sent to Berlin, where the Heereswaffenamt ordered that several captured Allied tanks, including the M4 Sherman, be transferred to European proving grounds for controlled evaluation. By the summer of 1943, one such Sherman was delivered to Kummersdorf, the German Army's principal weapons testing center southwest of Berlin. Engineers there, accustomed to examining captured Soviet T-34s or British Churchills, approached the American tank with clinical curiosity. The Sherman's rounded cast hull and welded turret looked primitive to their eyes, too simple to survive the rigor of German standards. Yet, as the systematic trials began, those same engineers found themselves confronting a paradox. What looked crude was, in fact, refined where it counted most. During a 500-kilometer endurance run, the Sherman's powertrain outlasted expectations. Its radial engine maintained consistent oil pressure, and its gear ratios delivered steady torque across varied terrain. The Germans measured temperature fluctuations, vibration frequency, and fuel consumption, noting that while the engine lacked the precision of German Maybach carburetors, its forgiving tolerances meant fewer breakdowns. The test drivers deliberately abused the clutch, shifted roughly, and drove the tank through mud and rubble to force a failure. None came. The suspension system, which they had dismissed as peasant design, proved extraordinarily resistant to wear. Compared with the torsion bar suspensions of the Panther prototypes, then notorious for sheared arms and cracked housings, the Sherman system seemed indestructible. In one internal memorandum, an engineer remarked that the vehicle appears to have been designed by production workers rather than draftsmen, a line meant as criticism but which inadvertently captured its brilliance. American engineers had built a combat tool, not a museum piece. The Germans dissected every aspect of it, the air filter, spark plugs, drive sprockets, and gearbox, and found them standardized and interchangeable. This was almost alien to a design culture that valued custom machining and exact tolerances. To the Germans, who had spent hours aligning Panther transmissions or recalibrating Tiger engines, the Sherman represented a philosophy built around the soldier, not the engineer. They performed comparative trials with a Panzer IV and an early Panther chassis, running each under identical conditions. After 200 kilometers, the Panther's final drive showed dangerous overheating, its transmission oil darkened from friction. The Panzer IV exhibited minor leaks from its hydraulic lines. The Sherman, by contrast, continued to function without measurable loss in efficiency. Maintenance crews could remove its engine within hours using basic tools, something unthinkable for a Tiger. The Germans recorded the turnaround time with disbelief. What they had considered simplified was in truth optimized for wartime practicality. What most impressed the evaluators was not performance in ideal conditions but consistency in adverse ones. Sand, dust, and rain seemed to have little effect. The sealed electrical system, though basic, resisted short circuits. Bearings lasted beyond predicted intervals. When stripped, the pistons and cylinders showed almost no scarring. Reports concluded that the vehicle's metallurgy, while not luxurious, was perfectly balanced for cost and durability. German tanks, built with hardened alloys and intricate machining, often suffered from brittleness or excessive maintenance intervals. The Sherman's materials, by contrast, reflected an industrial system capable of producing good enough parts by the hundreds of thousands. The Kummersdorf engineers drafted their summary with restrained language but unmistakable respect. They noted that the American tank demonstrates exceptional service reliability, its design sacrifices aesthetic perfection for functional longevity. For an institution obsessed with technical mastery, such acknowledgement was almost revolutionary. The findings were quietly circulated to design offices involved in the Panther's ongoing refinement, though few dared to admit how much could be learned from an enemy machine that simply worked. Behind those dry technical notes lay a deeper strategic revelation. The Germans realized that the Americans had engineered not just a tank, but a logistical advantage. A Sherman could be repaired in hours, rebuilt in factories overnight, and replaced in weeks. Every element, from the bolts to the fuel lines, was made to be reproduced in volume. The comparison was brutal. While Germany struggled to manufacture a few hundred complex tanks per month, the United States could ship thousands, each one predictable, standardized, and rugged. What the tests at Kummersdorf revealed was not a single machine's reliability but an entire nation's industrial doctrine, a doctrine that would eventually overwhelm even the most advanced German designs. By late 1944, the reports from Kummersdorf had circulated among various engineering bureaus and Panzer Command divisions, and a reluctant consensus began to take shape. The American M4 Sherman had achieved something Germany's armored industry could not: dependable, scalable reliability under real battlefield conditions. Despite the German engineers' pride, many quietly admitted that the Sherman represented a new kind of industrial warfare, one built not on perfection, but on endurance. Wartime memos from the Heereswaffenamt noted that the Sherman's simplicity allowed field repair units to return disabled vehicles to combat in less than 48 hours, while German workshops required days or even weeks to service a damaged Panther or Tiger. This difference was not merely mechanical, it was philosophical. The American belief that quantity and functionality outweighed complexity challenged everything the Reichsengineers had been taught about design supremacy. Captured Shermans pressed into German service, officially designated Panzerkampfwagen M4 748A, began appearing sporadically on the western and eastern fronts. Some were used for training or recovery operations, others rearmed with German radios or repainted for deception units. Reports from the 26th Panzer Division in Italy described the vehicle as surprisingly maintainable under stress. Even in improvised frontline repairs, the captured tanks rarely suffered mechanical failures. German drivers remarked that the steering system responded smoothly, the transmission rarely jammed, and the engine could tolerate fuel impurities that would cripple their own panzers. What once seemed a symbol of Allied industrial excess now stood as evidence of engineering pragmatism. In 1945, when Allied armies stormed through Germany, engineers from the American Ordnance Department found that the Germans had thoroughly documented the Sherman systems. Detailed measurement sheets, gear ratio analyses, and even metallurgical cross-sections were stored in crates at Kummersdorf and Stuttgart. These technical studies were intended to inform post-war projects like the Panther II and E-Series tanks, which sought to combine German firepower with simplified construction. Yet none reached production. The war had already shifted decisively toward mass-produced efficiency, a battle of factories rather than laboratories. For all their mechanical brilliance, the Germans had been trapped in their own perfectionism, designing tanks too advanced for their economy, too delicate for long campaigns, and too complex for fast repair. After Germany's defeat, many captured engineers found themselves interrogated by Allied technical teams. Their comments were revealing. One former Waffenamt inspector, when questioned about the Sherman's reputation, reportedly said, "It ran as if built for eternity. We built machines that demanded respect. They built machines that demanded nothing." That remark, though brief, captured a generational turning point in military design philosophy. Western industry after the war absorbed the lesson thoroughly. Standardization and mechanical forgiveness were worth more than intricate brilliance. The M26 Pershing, the Centurion, and later Cold War tanks from both NATO and the Warsaw Pact drew heavily on that principle: modularity, field repairability, and reliability over flare. The Sherman's legacy also echoed in post-war reconstruction. German engineers who had tested the vehicle were later employed by Allied or West German industries, including automotive firms that built the economic miracle of the 1950s. What they once called primitive design became a foundation for their new philosophy: cars and machinery meant to last, easy to service, and affordable to mass produce. In a quiet, indirect way, the Sherman's lessons outlived the war's destruction. Historians now view those German evaluations not as footnotes but as turning points in understanding how engineering philosophy can determine the outcome of global conflict. The Sherman was not the best tank in armor or gunpowder, yet it embodied the decisive principle of strategic reliability. Every machine delivered to the front worked predictably, every crew could expect it to start in the morning and keep moving through mud, snow, and shellfire. Against such reliability, even the feared Tiger's precision lost meaning. The Germans realized too late that modern war rewarded not craftsmanship but consistency, the capacity to produce functional machines faster than the enemy could destroy them. When the surviving test papers were reviewed after 1945, Allied analysts were struck by one repeated annotation scrawled in pencil across multiple German reports: Kein Pan, no breakdown. That phrase, written by engineers trained to revere precision and diagnose flaws, symbolized more than technical praise. It was an admission of strategic defeat through reliability. The Sherman had revealed that the ultimate measure of wartime engineering was not brilliance, but endurance, and in that measure, the Allies had already won long before the final surrender was signed.